All right, Unit 4 was all about factoring, which we have our big poster up there for. We had 4 methods of factoring. Five, sorry. First one was GCF, so we want to look to see if there's a GCF. Always. Second is difference of two squares. The third was a special case, which was a perfect square trinomial. We will look at those again. We can use the diamond method, or we can use bottoms up. Okay, so those are our 5 different kinds. So let's look at example 1.
Difference of two squares.
Okay, looking at example 1. The first thing we are always checking for is what? GCF. Is there a GCF in here? No. So the second thing that we want to look for is it a difference of two squares? No, it's not. Okay, is it a perfect square trinomial?
No.
No, it's not. So the last thing we want to look for? Is it a diamond method? Yes. So we're going to draw our diamond first. Okay, so we will draw our diamond. We're looking for 2 numbers that multiply to negative 36 and add up to positive 5. Can you think of any 2 numbers? Brandon?
7 and 7.
Okay, never mind. 2 numbers. Negative 4, positive 9. So we take those 2 terms and we plug those into the factored form, which means I take x plus 9 times x minus 4. And that's my factored form. If you have plus or minus 4 first and plus 9 second, it's the same thing, because in multiplication, order doesn't matter.
Is that it?
And that's it. That's your answer.
I love this.
Yeah.
The next one's hard.
Okay, example 2.
Oh, no, wait, you can use
25x squared minus 16. What's the first thing I'm always looking for? GCF. Good. Is there one? No. So we're looking to see if it's a difference of 2 squares. It is. How do you know it's a difference of 2 squares?
Wouldn't there be a perfect square trinomial with 25 and x squared and 16?
Okay, this is not a trinomial because how many terms are there? Just 2. This is a difference of 2 squares because let's look at it. Is 25x squared a perfect square?
Yeah.
Yes. Is 16 a perfect square? Yes. Are they being subtracted? Yes. So we get to apply our rule, which means I make 2 sets of parentheses. One is plus, one is minus. And what comes first? What's the square root of 25x squared? 5x. Good. And what's the square root of 16? 4. Are these factored completely? Is there GCF in either one of them? No. So we are done. So that's your answer. Okay, so we use difference of 2 squares there. In example 1, we used diamond method, so make sure you write that down. Okay, so example 1 we used diamond, example 2 we used difference of 2 squares. Example 3. Okay, what's the first thing I always look for when factoring? GCF. Is there a GCF in here? Yes. So let's write that down first. GCF. What is the GCF? 2. We were looking for the greatest common factor, so it's 2. So let's pull out a 2, which gives me x squared minus 4xy plus 4y squared. Okay, now let's get this. Is this factored completely? It's not. Look at this whole thing right here. First of all, what is this called? If there's 3 terms? Trinomial.
Perfect square trinomial.
Is this a perfect square trinomial?
Yeah.
Yes.
It is. What makes it a perfect square trinomial?
2 times 2 is 4, 2 times 2 is
X squared is a perfect square.
4.
4y squared is a perfect square. So, how do we factor that? Do you guys remember the rule?
Yeah.
We only have to make one set of parentheses,
And then you square it.
and it's all being squared. That's why we call it a perfect square trinomial. What's the middle sign there? Is it plus or minus? It's minus, so we put that sign in the middle. Okay, and square root of x squared is?
Wait, why is it minus?
Because our middle term is minus. So whatever, if this middle term was plus, it would be plus. One thing we always want to look for in a perfect square trinomial, perfect square tri, is the last term always has to be positive. Okay, so before I do this thing, will everybody look back up at example number 1? Example number 1 is a trinomial, correct? Is x squared a perfect square? Yeah. Is 36 a perfect square?
Yeah.
Yes, but how come it's not a perfect square trinomial?
5 is perfect square.
Because 36 is negative. The last term always must be positive in order for it to work. Okay? So that's why it's not a perfect square. So we could actually look at this as not a 36 but a negative 36. And that's not a perfect square. Okay? So that's the reason why example 3 is a perfect square trinomial, because it's a positive 4y squared. Does that make sense? Okay. What's the square root of x squared? X. And what's the square root of 4y squared? 2y. And that's my answer. On this term, instead of figuring out the perfect square trinomial, could I have used diamond method on this? I could have, and I would have gotten the same thing. Let's do that really quickly. So two numbers that multiply to 4 and add up to negative 4. No, not today. Okay, so two things that multiply to positive 4 and add up to negative 4. Negative 2 and negative 2, which is what we got here, right? When we FOIL it all out and we combine like terms, we would end up with a negative 4xy. This is what happens when you FOIL it. When you go the opposite way. Yeah. Okay. One reason why knowing perfect square trinomials is useful is, remember when we took the Unit 4 test and there were a ton of really, really big ones on there? Like they would give us 9x squared plus, I don't know, 18x plus 36 or something. I'm just making this up. So when they give you trinomials that have really big numbers, a lot of the time it's going to end up being a perfect square trinomial. So it's really helpful to be able to recognize it. Okay? Questions on that? All right, example 4. Here's an example of that. Okay, example 4, we have 25x squared plus 40x plus 16. What's the first thing I always want to check for first? GCF. Do I have a GCF? No, because of this 25. Is it a difference of two squares? No. Is it a perfect square trinomial? Yes. Look at it. 25x squared, is that a perfect square? Yeah. 16, is that a perfect square? Yes, it is.
But I thought you had to have a square.
You don't have to. Just for this specific problem, we did. 16 is still a perfect square by itself. Yes.
So, why wouldn't 25 be perfect square and x squared?
Okay, so what is my rule for perfect square trinomial again?
Parentheses.
I make one set of parentheses. I square it. And what's the sign in the middle this time? It's a positive. Okay, what's this first term going to be? 5x. And what's the second term going to be? 4. How did you get each of those?
Divide.
You took the square roots. Yeah. Okay? And that's your answer. We took the square root of 25x squared, and that gave me 5x. We took the square root of 16, and that gave me 4. This is just a special rule. It's like when we do difference of two squares, and we just follow the special rule. This is a special rule. If you were to FOIL it all out, that plus 40x would come back. Okay? But for factoring, breaking it down, we don't have to worry about it in a perfect square trinomial. Okay? All right, example 5. Four x squared plus 11x plus 7. What method will I use here? Okay, let's go through the list. Is there a GCF?
No.
No. Is it a difference of two squares?
No.
No. Is it a perfect square trinomial?
No.
No. Can I use diamond?
No.
Okay, who says yes, raise your hand. I can use diamond. Who says no, I cannot use diamond? Those of you that say no, what method will you use?
Bottom up.
It is a bottoms-up question.
Oh, you tricked me.
Okay, bottoms up. How did you know it was bottomed up? Somebody that's voted for yes. Yeah.
Because there's a number in front of it.
Very good. There is a number in front of the x squared, so we cannot use diamond here. Okay. We first checked if there is a GCF. Remember, if there is a GCF in the expression and you do not factor it out, bottoms up will not work, which is why we always check for GCF first. Okay? If there's a GCF in there and you don't factor it out, bottoms up will not work. Okay? Okay, so what is my first step of bottoms up, Brandon? What's my first step of bottoms up?
Isn't it, you have to put the thing on,
Okay, our first step of bottoms up is we take that 4 and we move it to the back
oh, that's what it was.
and multiply. So this x squared plus 11x stays, plus 4 times 7 gives me 28. Okay, what is my next step, Jared?
You wanna do diamond?
I can do diamond on this, so let's do our diamond. I'm looking for two numbers that multiply to 28 and add up to positive 11.
I'll do 27.
The last number is what we're multiplying to.
7
The bottom number is what we're adding to. 7 and 4. Thank you. So this factors to x plus 7 times x plus 4. So I'm done, right?
No, you have to do the bottom of the thing.
I have to do the bottoms up part. Okay, very good. Remember, at the beginning we multiplied by 4. So now we have to undo that by dividing by 4. Okay, Colton, what's my next step?
Divide that and you put the 7 over 4, you put the 4 in front of it.
Uh-huh. Yeah, I reduce everything first. 7 over 4 does not reduce, but 4 over 4 does, right? To 1. And then I take those bottoms, whatever's left, and bring it up. So how does this whole thing factor out? 4x plus 7 times? Very good, x plus 1.
How do you get 4x?
That's where bottoms up gets its name. Remember how we divide by 4? Whatever does not reduce comes up in front of the x's.
So that number, that 7 always stays there.
That 7 will stay there because we couldn't reduce it at all. Correct. All right. So now we're going to use factoring to actually solve for x. The reason we can solve is because now we have equal signs. What we want is we want the whole thing to be equal to 0. I'm going to factor it all, and then what would I do? Do you guys remember?
Or no, you would.
We set them all equal to 0. So let's do it, okay? What method will I use to factor this? Good, diamond. So let's label that diamond. Okay, and then let's use the diamond. I'm going to do mine off to the side. I'm looking for two numbers that multiply to what? Negative 28 and add up to negative 3. What are they? 4 and 7. Which one's negative? 7. Okay, so let's factor that out. So this is x plus 4 times x minus 7 equals 0. And then I set each factor equal to 0. So I'm going to rewrite it up here. X plus 4 times x minus 7 equals 0. Okay, and then remember I drew a line in between the two. And I set x plus 4 equal to 0. And x minus 7 equal to 0. X plus 4 equals 0. How do I solve that one? Good. I subtract 4 from both sides. So x equals negative 4. And then the same thing here, but I add 7. And I get x equals 7. So I have two answers here. X equals negative 4 and 7. Now remember, we can only do this if the problem has an equal sign in it from the beginning. We can't just set it equal to 0 if there's no equal sign to begin with.
What if it's equal to a different number?
If it's equal to a different number, like example 7,
Yeah, then you just, instead of x plus 4 equals 0, you'd put x plus 4 equals 6.
no, we do not. Okay, so let's look at example 7. What happens if it's equal to a number and not 0?
You just subtract that number.
Very good. We want to set it equal to 0. We cannot do this thing, unless it's equal to 0. That's the only way we can do it. So for something like example 7, we have to set it equal to 0. And how can we do that?
Subtract 6.
We can subtract 6 from both sides. So what does that make my problem?
X squared minus 5x minus 6
Very good. X squared minus 5x minus 6
equals 0.
equals 0. What method will I use to factor this? Diamond. So I'm looking for two numbers that multiply to negative 6 and add up to negative 5.
Negative 6 and 1.
Negative 6, positive 1. So let's factor that. X minus 6, x plus 1 equals 0. Oops, 1. Okay, and then what do? I set them both equal to 0. So x minus 6 equals 0. X plus 1 equals 0. I add 6 to both sides. And I get x equals 6. And x equals negative 1.
Wait, doesn't matter what order?
No, the order doesn't matter. Example 8. 2x squared plus 3x minus equals negative 1. Is this set to 0 yet? No, I need to get it equal to 0. So I'm going to add 1 to both sides. And that's going to give me 2x squared plus 3x plus 1 equals 0. And what method will I use for this one? Bottoms up, because there's a 2 in front of the x squared. So we're going to multiply 2 times 1. So that gives me x squared plus 3x plus 2 equals 0. We can factor that using diamond. X plus 2, x plus 1 equals 0. And then we divide both sides by 2. Those 2's reduce to 1, and then I bring the other bottom up. So this thing whole factors to x plus 1 times 2x plus 1 equals 0. Now what? I set them each equal to 0. So x plus 1 equals 0. 2x plus 1 equals 0. This one on the left is easy. We subtract 1 and we get x equals negative 1.
Wait, hold on.
And then for this one, I subtract 1 from both sides, so I get 2x equals negative 1. Divide by 2. So x equals negative 1/2. So my two answers in this case are x equals negative 1, negative 1/2. Because I had a 2x equals negative 1, and I'm solving for x, so I divide by 2. Okay, example 9. If x squared is added to 2x, the result is 35. Write an equation and solve for the values of x. So how would I do this? First, let's write an equation using this sentence. What would my equation be? X squared plus 2x equals 35. That's your equation. Okay, how do I solve this one? I subtract 35 from both sides. Okay, so that's going to give me x squared plus 2x minus 35 equals 0. What method will I use here? Diamond. So I'm looking for two numbers that multiply to negative 35 and add up to positive 2.
7 and 5.
Positive 7 and negative 5. So that's going to give me x plus 7 times x minus 5 equals 0.
7 to 0.
And then I set them each equal to 0. So x plus 7 equals 0. X minus 5 equals 0. So I get x equals negative 7 and positive 5.